Okay, we've been doing a bunch of algebra and factoring. I think it's time to take a look at a bit of a review so we can put everything together. So we started out with some expanding and simplifying, and I've kind of set it up in a little table here so it's all together. We have the distributive property and we have FOIL for expanding and simplifying. So the distributive property, remember, is when you take whatever's in front of the bracket and you multiply it to everything inside the bracket. So in this case, let me just make my pen thinner. In this case, I'd have 4 times 2x squared. So it's just a number, so I'm just going to multiply the numbers like normal to get 8x squared. And then I have 4 times minus 3x. Don't forget, 4 times minus 3 or negative 3 makes negative 12. And don't forget to bring along the x. And last but not least, 4 times 5 would give me 20. Or I could have something like this. Instead of a number, I'm multiplying by a letter. So each piece gets multiplied by a letter. Remember, to multiply letters, you're going to add the exponents. So x times x, the 3 stays the same. Or you could think of it like 1x times 3x. And 1 times 3 is 3. And x times x is x squared. And then 1x times minus 7 would be minus 7, and you bring along the x. So remember, to multiply letters, we want to add the exponents. So other things about the distributive property. So we multiply by a number, we multiply by a letter. We can multiply by both a number and a letter. Always remember to multiply everything in the bracket by what's in front of it. And watch your signs. So I have negative 2 times 5. It's going to give me negative 10. And x times x, x squared. Exponent of 1 plus exponent of 1 is an exponent of 2. And then I have negative 2x times plus 3. A negative times a positive equals a negative 6, and I bring along the x because there's no other letter to multiply by. And then the last one is just kind of 2 of the previous example put together. So if I have 2 of them, there's my bracket. I'm going to multiply both of those by 2x, but then I hit another bracket. And that bracket tells me to stop multiplying by 2x. And then I move along and I have a second bracket. And the second bracket tells me I'm going to take what's in front of it and multiply both of those by something different. And then I hit another bracket that tells me to stop multiplying. So when I do my first batch of multiplying, I'm going to have 2x squared minus 14x. And when I do the second batch of multiplying, I'm going to have 6x squared minus 6x. And this one's a little bit different because now I get to go a step further. I get to go a step further because we have like terms. So the last thing you always want to check is to see if you have any like terms once you've multiplied. So I have my x squared terms. When I put them together, 2 of them plus 6 more make 8x squared. And I have my x terms. When I put them together, negative 14 minus 6 more is negative 20x. So remember that when you're multiplying letters, you're going to add your exponents. And remember that you want to look for like terms at the end. So you always want to collect like terms to finish. So that's one type of multiplying, when you've got something in front of a bracket and you multiply everything by the bracket, everything in the bracket by what's in front of it. Another kind of multiplying is this idea of FOIL. And the difference between FOIL and what we just did is if you look at the brackets, there's 2 pieces in each bracket. And the questions we just did had 1 piece in front of the bracket. So when I have 2 pieces in each bracket, I'm going to multiply the first in each bracket. I'm going to multiply the outside in each bracket. I'm going to multiply the inside and the last to make sure I multiply all of them together. So x times x, x squared, minus 5x plus 2x minus 10. And I'm left with some like terms to put together here. Minus 5x plus 2x is minus 3x minus 10. So FOIL has the same pattern every time. So if I look at my next question, I'm going to multiply the first terms together. I'm going to multiply the outside terms together, the inside terms, and the last terms. And I do my multiplying like normal. So the first terms are 8x squared, the outside terms are negative 2x, the inside terms are minus 12x, and the last give us plus 3. So that gives me like terms put together. And when I put the like terms together, be careful with your integers. I have minus 2, and I'm taking away 12 more x's, which gives me minus 14x plus 3. And I can continue on and look at different kinds of FOIL questions too. This one's a special one because the brackets are what we call conjugates. The brackets are the same, but for the sign. But we do the same thing when we FOIL it, when we get rid of the bracket. So I multiply my first terms together, x squared. I'm going to multiply my outside terms together, minus 5x. I'm going to multiply my inside terms together, plus 5x. And my last terms, minus 25. And then I'll collect my like terms, except this time, when I collect my like terms, if I have minus 5x's and I add 5x's, I'm going to end up with 0 x's. So I have no x's, I just have minus 25. And that will happen every time you have the same brackets except for the sign. Every time that pattern will happen. So every time that you multiply two brackets that are the same, except one's plus and one's minus, you will have no x term. It'll just be x squared and a number. All right. Oh, I didn't leave much room for this one. We'll see what we can do. Other thing, when you're squaring it, anytime you square something, it means you take whatever is being squared and you multiply it by itself. So that becomes a FOIL question, which gives me 9x squared plus 12x plus 12x plus 16. And I'm going to have to scooch down here a little bit because I didn't leave myself enough space in my table. 9x squared plus 24x plus 16. So just watch. Let me pull out a different color here. When you have a squared, to evaluate it, write out the bracket 2 times. Maybe I'll put times instead of x because that looks like an x. Write out the bracket 2 times and then FOIL so that you don't miss any multiplication. So that, ladies and gentlemen, is algebra. We're either FOIL or distributive property. Shoot. So when I'm factoring is the opposite of expanding and simplifying. Basically, I'm giving you the answer and I want to know what you multiplied to get that answer. So you will notice that this answer in a trinomial looks a lot like what I got from foiling. That means what I multiplied to get it started out with 2 brackets. And if you look at our FOIL question, every bracket has an x at the beginning. So every bracket has an X at the beginning. And then we talked about in our notes, to figure out the rest of the brackets, we want to know what multiplies to get that number, and those same numbers have to add to get that one. And you can make a whole list. 1 and 6, 2 and 3, -1, -6, -2, -3. But I know from practice, the numbers I'm looking for are 2 and 3. Because if I do 2 times 3, I get 6. And if I do 2 plus 3, I get 5. There's my factors. So to factor a trinomial, it's the opposite of FOIL. I want to come up with the two brackets. And to come up with the two brackets, I've got X at the beginning, what multiplies to get 10, and adds to get -7. The better you are with your times tables, the easier this is. The better you are with integers, adding and subtracting them, the easier this is. So if I want to multiply to get 10 and add to get 7, I know 2 times 5 is 10 and 2 plus 5 is 7. And to get -7, I'd have to make them both negative. And when I multiply two negatives, I get a positive. So there's my factors. All right, this last guy does not look quite the same. It's missing an X term. All that means when it's missing the X term is that when you add them, it equals 0. And if we go back up here, we will notice right here, there was no X term. And what did that come from? Well, that comes every time we multiply the same brackets, but different signs. So I know when they add up to 0, when there's no X term, I'm going to have exactly the same brackets, but different signs. So I need the same number that multiplies to get 16. That would be 4 times 4. So one will be plus and one will be minus. And this one looks a little different again. It does not have the number at the end. That means that when we use our pattern, it multiplies and equals 0, and it adds to 8. So to multiply to equal 0, we talked about in the note how one of the numbers would have to be 0. And so to add up to get 8, then I would have to have 8. And if it's x plus 0, it's really just x. And so I've got my factors. All right, so factoring trinomials is the opposite of FOILing. Common factoring is the opposite of the distributive property. It's the opposite of multiplying or expanding and simplifying. Common factoring is when you divide by the greatest common factor. So when I look at this question, 3 and 18 both divide by 3. So I write down the 3, and in my head, I divide them both by 3, or I write down that I'm dividing by 3, whatever works. And 3 divided by 3 leaves x, and 18 divided by 3 is 6. So the idea is, if I look back at these questions, I have a number in front of a bracket and it expanded out. Now I've got my number in front of the bracket, and if I took off the bracket, I would get that answer. So common factoring is dividing everything by the greatest common factor. So next one, 2 and 5 don't divide it by anything, but they each will divide by x. So it's like taking an x out of each one. Other thing, good form in math, if there's a negative at the front, usually we'll divide by -1 as well to get rid of that negative. So -2 divided by -1 is 2. X squared divided by x leaves x. So it's kind of like you're taking away an x. Remember when we did our exponents, to divide letters, it's the opposite of multiplying. When we multiply letters, we add the exponents. To divide letters, we subtract the exponents. So an exponent of 2 Take away the 1 that we're dividing by, leaves 1. If I divide minus 5 by minus 1, I get plus 5. And the exponent of 1, take away an exponent of 1, would leave 0. So there's no x's. So if I think about what I'm doing, that would mean if I went back and checked my answer, I did the opposite, and I removed the bracket. If I did this times this and this times this, I should get what I started with. All right, 2 more quick ones of common factoring. Sometimes these guys are tricky. So if I look at this one, it looks like a trinomial. It's got an x squared, an x, and a number, but there's this number in front of the x squared, 4. So when that happens, I want to divide by the greatest common factor, and hopefully that's 4. So I can get rid of that number in front. So 4 divided by 4 is x squared. Minus 8 divided by 4 is minus 2x. And 24 divided by 4 is 6. There we go. I common factored everything by 4. I'm going to look at this next one. Same thing. They're all even numbers, so I'm going to common factor, divide them all by 2. Sometimes it gets really tricky. And I look at these 2 questions and I know from experience that the second one I can keep going on. And I know I can keep going on it because I can multiply 2 numbers to get 6 and I can add them to get 5. We already did that if you were paying attention right up here, the very first trinomial question. Sometimes when you common factor, you can factor again. And by factoring again, I factored the trinomial that was in the brackets using the pattern for trinomials. So sometimes you can common factor and then factor again using a trinomial. So be careful of that. Okay, so that is a summary of the algebra that we've done so far. You're going to have some questions here to work on, and you're going to hand those questions in to be marked.